Good evening. Well, as you can see, I'm not in a BBC studio. I am, in fact, at Newcastle on Tyne, at Frank Acfield's observatory at Forest Hall, and we're delighted to have Frank with us for this evening's Sky at Night. This very neat and efficient-looking dome contains a 10-inch reflecting telescope. And just to make sure that we all know where we are, the latitude and longitude is given on the door.
Yes, this was given to me, Patrick, by the Royal Greenwich Observatory, who gave it to me in order to pinpoint my position if I sent in any observations.
This dome's entirely different in construction and design from my own down at Chelsea, and for one thing, it's made of entirely different material.
Yes, Patrick, actually it's made of rubberoid roofing felt, reinforced with wire netting underneath to stop it sagging in case of any weight of snow or anything on top of the building, you know.
Do you find any trouble with heat rising from the inside?
No, because the light colour reflects all the radiation that falls upon it. That's why it's painted with aluminium paint.
Well, it looks very workmanlike, and it also looks very new, but of course I know it isn't.
No, it's been here 21 years.
How did you get it? Did you make it yourself?
No, I couldn't make anything. I'm sorry, Patrick, I'm not able to construct things on my own. But actually what happened was this. I gave some lectures to the Newcastle Astronomical Society. And after those lectures were given, a gentleman came up to me, who I did not know at the time, and he said that he'd enjoyed the lectures very much indeed, and he would like to do something for me. Mm-hmm. And I thought, by Jove, what's coming now? And he said, I would like to build you an observatory. And at that time I had the telescope mounted just in the open. And I was delighted to hear I was going to get some shelter.
I imagine you were, yes.
Actually, what happened was this. I provided the material and he provided the brains and the labour. And he spent 12 months cutting by hand every piece of wood for the framework of this building. And, as you see, made a really first-class dome which has kept out wind and weather for all these years. And I'm extremely grateful to him. He was Mr. John Crofton of Newcastle on Tyne.
Well, you certainly made a magnificent observatory. I know it's a difficult thing to answer, but have you any idea of what it would cost if you set out now to make or build this dome?
Well, I can hardly give you a figure, because actually I don't know what this one cost me. You know, you gradually build up these things over a period of time, and of course, costs in those days were very much less than they are now. I mean, 21 years ago, the material was vastly cheaper. I suppose it would cost 5 or 6 times as much as it did originally.
Do you find that the dome's easy to turn?
Yes, once you get it going, Patrick, it's quite easy. Look here, you see. Just you to have a try.
Yes. Well, that's pretty easy. There's no difficulty there.
No.
Well, it's a very nice observatory. Well, now let's go and have a look at the telescope.
Yes, do. Come and have a look inside.
All right. Well, you've told us about the observatory. What about this very fine 10-inch reflector?
Yes, Patrick. This reflector was made for me by Mr. Tom Whittam of Newcastle, and he came to me and said he didn't like the mounting I had. It didn't fit the lovely observatory. Would I allow him to make mounting equal to the beautiful building in which it was housed?
Let's have a look at the mirror. That's a very nice mirror indeed. Do you always have it illuminized rather than silvered?
I do, Patrick, yes. It's illuminized on the face and anodized on top so that you can dust it, you know.
What's the focal length?
90 inches.
And there, at the bottom of the tube, you can see the 10-inch mirror, which is the essential part of the whole telescope. One thing I like particularly about this telescope, you know, is this massive, firm mounting.
Yes, it is a solid mounting, and it's powered by an electric gramophone motor, which you see here. Now, I'm just going to switch it on, Patrick, so that it is actually driving the telescope to counteract the Earth's rotation. The telescope is now moving toward the west, and although you can't see the movement, this is very obvious when you look through the eyepiece.
It certainly is. I like your circles, too.
Yes, this right ascension circle was actually made from a piece of curtain rail, and as I rotate it, you can see the hours of right ascension passing by there. The minutes are also graduated, and here I've come to the position where the circle is joined by the screws there onto number 1 hour, and the whole thing making up the 24 hours of the circle of the sky.
Do you find this equatorial fork design of a mount absolutely satisfactory?
Yes, I do, Patrick. Very satisfactory indeed.
In a Newtonian reflector, such as this one, the eyepiece is at the top of the tube, so you look down into it. And what happens is that the light goes down the tube till it hits the mirror at the bottom, and is then reflected back up the tube onto a smaller mirror, or flat, and directed into the side of the tube, where the image is formed and magnified by the eyepiece. Frank, can you show us how you focus this one?
Yes, I'm now going to focus it, Patrick. There I'm just turning the screw to bring the eye adjustment to the correct amount.
You know, there are plenty of people who write and ask, what is the magnification of a telescope? And the answer is that it's not really a question you can answer just like that, because the magnification depends upon the eyepiece. The function of a mirror in a reflector such as this one, or an object glass in a refractor, is to collect the light, and the actual magnification is done by the eyepiece. And you can alter that around so that every telescope, such as this one, has a whole battery of eyepieces of different magnifications. Some low with wide fields and some high powered. How many have you got altogether?
I have 8, and my low power is 45, going up to 600, Patrick.
That's a very considerable range, and of course it is absolutely essential for this kind of telescope. And then lastly, we have the camera with which these very fine photographs are taken.
Yes, this camera has no shutter. No shutter is necessary, because always the exposure is one of minutes rather than seconds, and sometimes even half an hour or an hour. Exposure is given. The plate which is used is put in here in place of this ground glass which you see here, and the photograph is made with the required exposure and then the lens covered.
When you're making a time exposure, do you find that your drive is absolutely adequate, or do you have to go and keep on hand guiding it with the finder?
You always have to hand guide. Yes, always have to hand guide. You can never do an exposure without checking, because you get all sorts of variations on the mains and all sorts of variations in the drive. Nothing is perfect in this mechanical sense. It must be guided by hand.
I think you're very wise, too, in doing your developing and processing actually on the spot.
Yes, this is my darkroom, Patrick, and what I do is this. I have my developer and my hypo here. Then I put my plate into the developer, having my hands in the hand holes here, and I'm able to rock the dishes for the required time at the required temperature. Once this is done, I can remove them, wash the plates, and then transfer them into the enlarger here. Then if you have a picture like this, say, and wish to enlarge it, then simply by moving this height up here, then you can enlarge from a picture like this to a picture the size of the table.
This is one of Frank's pictures of the full moon, taken with the 10-inch reflector, of course. And on this photograph, you can see the great ray crater, Tycho, near the bottom of the picture. You can see the Sea of Showers, and you can also see the areas where the first 2 lots of astronauts came down. Apollo 11 in the Sea of Tranquility, over to the right-hand side of the picture, not far from the middle, and Apollo 12 in the Ocean of Storms, rather to the left of center. Well, it's a wonderful observatory, Frank. Well, let's go outside now and have a look at the rest of your equipment.
Yes, thank you, Patrick.
Well, from the 10-inch equatorial reflector to a 4-inch altazimuth refractor, rather like one that I've got myself. Well, a reflector, such as the one we saw inside the dome, collects its light by means of a large mirror. And a refractor hasn't got a mirror, it uses a glass lens or object glass. Well, you may wonder why people want 2 telescopes. And the answer is that they do very different kinds of things. And I think probably that, like me, Frank, you find this little refractor a very useful supplement to your big reflector.
I do indeed, Patrick. I tell you what I use it for, the sun. Because you realise the 10-inch reflector is pretty well useless for the sun because of the tremendous amount of light and heat you gather, whereas this 4-inch refractor is ideal, especially for taking photographs of the sunspot.
Well, I'm a great admirer of your sunspot pictures, and I've been looking at this camera.
Yes.
It looks a homemade thing, and I mean this in the best possible way.
It is actually a homemade camera box, simply a plate holder. It was made by a friend of mine, Raymond Lane of Newcastle, and you see here how this fits onto the telescope. We first of all remove the eyepiece from the refractor, take out this draw tube, fit the camera onto the draw tube piece here, and then insert this into the telescope. Then focus the image of the sun onto the ground glass, which I have here. Once the image is focused so, then all you have to do is to remove this carefully, insert your plate holder. This is a double plate holder, and you can use either side, so you have two chances. Put that in there, lift this so that the plate is then able to be exposed, and then with this shutter release you just press so, and the shutter clicks across, giving an exposure of about 200ths of a second.
So you don't need any kind of drive on the telescope?
Not at all. No drive is necessary at all, because you freeze the image too, you know, at high speed.
Well, let's have a look, I think, at some of your magnificent sunspot pictures. Well, these are some of the pictures that Frank has been taking with his 4-inch refractor. And here you can see a very disturbed solar disk. This one was taken on June the 8th, 1969, and there are many large spots there. And on the view on June the 11th, you can see once again that the spots are moved, and you can recognize the same groups. And these spots, remember, are not really dark. They only appear so by contrast with the even brighter sun's surface in the background. And here we see some enlargements of the groups, and as you can see, the structure is very intricate indeed. These were taken with the 4-inch refractor. You'd never try and observe the sun with the big reflector, of course, because you collect very much too much light and heat, and this is the kind of work that the amateur can do. Up to now, we've been talking about equipment which is, by everyday standards, decidedly expensive. Although, of course, the expense is non-recurring, and once you've got your telescope, you've got it. But here on this table, we've got some equipment which is very much less expensive. We have a small telescope, actually a terrestrial one, and a pair of binoculars. You know, I'm asked many times every week how one starts taking up astronomy as a hobby, and I always give the same answer. You don't, in fact, need any optical equipment whatsoever, and you certainly don't need a large and expensive telescope. And my advice is that if you want to start taking a real interest in astronomy, the very first step is to buy a star map, which only costs a shilling or two, and then go out and learn your way around the sky, learn your constellations. And this doesn't really take very long, and the stars become so very much more interesting when you know which is which. At the present moment, for example, if you look up into the southern sky, you will see one very bright thing there after dark, and that is the planet Jupiter. And this is so bright that you can't really mistake it. In the evening sky, there's only one object which is still brighter, and that is the planet Venus, which is further west and sets much earlier. Now, look at either Venus or Jupiter with the naked eye, and they appear like very bright stars. So what kind of equipment do you need to see anything on them? Well, certainly not a 100-pound telescope. Consider, for example, a pair of binoculars. If you look at Jupiter through binoculars, you will see that the planet has got various small stars beside it. 4 of them, if your binoculars are good ones, and those are Jupiter's 4 big moons. And if your binoculars are good, you will see them without much difficulty. Then, for example, look at the planet Venus, and you can't mistake that either because it is so extremely brilliant. That's in the western sky now, immediately after dark, and you can even see it before sunset. Look at Venus through binoculars at the present moment, and admittedly, you won't see very much except a little disk. But later on this year, around about September, early October, when Venus is still visible in the evening sky, and you use binoculars, you will see that Venus looks like a little crescent moon. And that's because its phase is quite easily seen with binoculars of any power at all. Of course, one thing one's got to bear in mind straight away is the question of cost. If one's only got a very limited amount of money to spend on equipment, and this certainly applies to most of us, then there's a straightforward choice between a very small telescope or a pair of binoculars. And I'm going to give my own views here with the full knowledge that they're open to challenge. I personally wouldn't pay a great deal of money for a very small astronomical telescope because it's going to have a small field and it's not going to have any real advantage over good binoculars. And personally, I wouldn't recommend spending a great deal of money upon any astronomical telescope with an aperture smaller than 3 inches for a refractor or 6 inches for a reflector. Smaller telescopes than that can be got, and they are quite nice, but personally I'd rather go in for binoculars. And binoculars are going to show you a great deal. They'll show you the craters of the moon, they'll show you the 4 big moons of Jupiter, they'll show you the phases of Venus, and all kinds of star fields, double stars and star clusters. Binoculars come in various kinds. This particular pair happens to be 8 by 30s. That means it has a magnification of 8 times, and the object glasses are 30 millimeters in diameter. And that gives you quite a nice broad field. And so far as cost goes, well, you're going to get quite a good pair of binoculars for £10 or less, and in my view, that is a better bet than an astronomical telescope of comparable price. I think probably that the best all-purpose pair of binoculars is a 7 by 50, but of course if you can get more than one pair, it's a good idea also to get something larger with a greater light grasp. And if you go on and get a pair of, shall we say, 20 by 70s or something like that, which is admittedly going to cost more money, then really it's a good idea to fix up some kind of improvised mounting, because the field is going to be small and it's not going to be easy to hold them steady. But again, this is a matter of personal preference. There's one question that I'm always being asked, and I think it's worth answering on the air, and that is, how does one become a professional astronomer? Because I get asked this by many people the age of 10 upwards. Now, the answer is quite definitely that for professional astronomy, you have got to have a science degree. And without a science degree, it's no good even contemplating a career in astronomy. The degree needn't actually be in pure astronomy. It can be in physics, and this is very often done. But you've got to have it, and that means first taking the right GCEs, which means A-level in maths and physics and another science subject, and the usual string of O-levels as well. And when that has been done, it's possible to start a degree course. But without it, there are no prospects in professional astronomy. And, of course, all professional astronomy is mathematical, and so if you're going to be an astronomer professionally, you've got to be a good mathematician. And let me hasten to add that this does not apply to me, and I am purely an amateur. And it's interesting to note also, you know, that astronomy is still just about the only science where the amateur can still do useful work and where his collaboration is welcomed by the professionals. But it's not only the fact of doing useful work, you know. One can get a tremendous amount of fun out of amateur astronomy, and that was a point that Frank Acfield made to me a little while ago, and I think you'll agree on this, Frank.
Well, I think this is a point that's worth making, Patrick, because after all said and done, it's the same with everything else. You can play games, you can be a wonderful golfer, and yet not earn a penny out of it,
right,
and get great joy from it. And after all, the sky gives of its own greatness. And I think this is absolutely lovely.
And of course one can do it with that kind of telescope quite easily.
It's a telescope like this. Here you have
yes,
a telescope, you see, with a 4-inch object glass, and you can do a lot of work with this. And I'm sure that anyone who goes in for a 4-inch refractor can have really a great deal of benefit from it. Don't you think so?
I'm absolutely certain about this, because astronomy is unlike anything else, and one can give as much or as little time to it as one wants to do.
Yes.
You can still get a tremendous amount of enjoyment, and if you do useful work as well, so much the better.